The threat is such that a falling object would force us to evacuate entire regions. Or will scientists find a way to deal with space rocks?
If a dangerous asteroid is detected in advance, several years before, like 5 years, 10 years prior to a potential collision with Earth, it is always possible to change its orbit. What ways are there to do it? That's a different question. But nowadays, systems are being developed to remove an asteroid from a collisional orbit. For example, by using a laser beam from a spacecraft, or actually on the asteroid.
The D-Star project in America has existed for 10 years. It plans the launch of a powerful laser gun with solar batteries into space. The batteries are just over a half-mile long, so we'll have to assemble the gun in orbit, not on the ground.
With the help of such a device, it is planned to influence asteroids with the help of a laser beam in the future. The orbit of a dangerous asteroid is supposed to be changed by evaporating the substance from the surface of the asteroid with a temperature of up to 3,000 degrees Kelvin or 5,000 degrees Fahrenheit.
A huge space laser gun seems like something out of a sci-fi movie. But back in 2005, NASA, for the first time in history, attacked the comet Tempel 1, dropping a metal probe onto it. It rammed the surface, causing the release of matter weighing about 10,000 tons. All of this was done to analyze the composition of the comet. But at the same time, it paved the way for an experiment called DART. It will help NASA experts understand how asteroids would behave if attacked by a metal shell about the size of a domestic refrigerator.
The impact will happen at a speed of 15,000 kilometers per hour. That's 10 times faster than a bullet. The target will be a double asteroid, Didymos, which is at a safe distance from Earth. It consists of 2 asteroids with a diameter size of 2,500 and 500 feet. The small one revolves around the bigger one. In 2022, DART will hit the smaller object, slightly changing its orbit.
NASA experts say that the small asteroid will eventually change the trajectory of the larger one. Nobody knows whether this courageous experiment will succeed or not. However, many Russian scientists believe that the impact probes are useless against the large, single asteroids, and they propose fighting fire with fire.
Another method, which also seems technically feasible, is to collide smaller asteroids with bigger and more dangerous ones. These asteroids are smaller than 30 to 20 feet in size.
To implement this idea, a spacecraft needs to be attached to an asteroid. Then, with the help of rocket engines, it will send a small asteroid towards the big one, colliding into it like billiard balls.
If an object with a mass of a couple of thousand tons collides with a dangerous asteroid, it will be enough to divert it from its collision orbit. So it should work. No technical obstacles are visible, although the latest and most cutting-edge achievements of space technology must be put to the test.
You can send an asteroid into what's known as free flotation, which, with the help of a solar sail, this refers to a light mirror which reflects light rays, thereby accelerating the spacecraft. A solar sail uses the pressure of sunlight, photons, and charged particles, just like an ordinary sail uses air pressure.
This technology is often used now and was first tried in 1993 on the Russian spaceship Progress. Then the Japanese and Americans conducted successful tests of the solar sail as a full-fledged engine for light spacecraft. But is a solar sail capable of moving a block weighing tens of thousands of tons from its orbit? Theoretically, it's possible, but sunlight's pressure is very small, and it will take several years of work to divert an object onto a safe trajectory. Therefore, in a few years, we should already know for sure if a certain object will be dangerous for us.
But what if humanity is simply out of time to plan a mission to install an engine on a meteorite? Perhaps we will use a nuclear weapon, but international policies might get in the way.
The deployment of nuclear weapons in space is prohibited by an international treaty that came into force on October 10, 1967. When an asteroid speeds towards Earth, can the leading powers negotiate and mobilize resources to repel the threat? And if each country decides to defend itself by any means, what consequences will this have for the planet?
Scientists are unanimous. A poorly prepared nuclear attack on an asteroid will only aggravate the situation. Instead of a single object, we will have dozens and even hundreds of large pieces. Thus, the area of damage will only increase, and it will be much more difficult to predict where the fragments will land, as opposed to a whole asteroid.
If you crush an asteroid into pieces the size of a brick, and they stay connected and close-fitting, it's quite possible that it will pass through the atmosphere as a single object, and this isn't going to help us. Calculations made suggest this scenario is possible. Therefore, we need to crush it further away from Earth, so these pieces disperse and each one flies through the atmosphere independently. Such a meteor shower can have many negative consequences, but it will be less dangerous than the fall of a single body.
Unfortunately, now we do not have the technology to deliver a nuclear weapon to outer space. NASA and Roscosmos only recently started to be concerned by possible meteorite threats. Russian nuclear physicists are now doing model calculations to discover which atomic bombs would be most effective against asteroids. Can you blow them up on the surface, or do you need to drill a hole deep into the celestial body?
If you explode a bomb on the surface of an asteroid, its deflection or dispersion consumes about 15% of the released energy. But if you blow it up under the surface, not at a very great depth, like 10 to 20, 30 miles, then 90% of the energy is released and directed towards the asteroid. And this ejection will deflect its movement. Then we need to look at how far this has happened from Earth and whether the impulse is strong enough for it to pass by us or not.
In addition, there are various types of asteroids: rock, metal, and ice, and we must deal with each of them differently.
Because the object can be loose, consist of lumps which are somehow connected there by ice and so on, or it can be monolithic. We need to investigate it to make sure we won't create even more problems for ourselves when, using a chosen method, we begin changing its orbit. In the Makeyev Rocket Design Bureau in Russia, the designs of two aircraft, Kapkan and Kaisya, have been developed. One is to investigate an asteroid, determine its physical and chemical characteristics, specify the orbit, because if the object has only been discovered, its orbit is not well researched to understand its future path. The Kaisya spacecraft is used for this, and then the second spacecraft is used, if it is necessary to change the orbit or to destroy the body.
The second spacecraft, called Kapkan, is supposed to carry a nuclear weapon. The implementation of these proposals would protect the planet from asteroids measuring 2,000 to 2,300 feet. But unfortunately, we have not yet begun constructing these devices.
Theoretically, they are there on paper, in publications, in conference minutes, and presented only in this way.
Apparently, protecting ourselves against asteroids is a very international problem. At any moment, an unwelcome guest from outer space, even from another galaxy, can knock at the door of our planet. On October 19, 2017, NASA astronomers first discovered such an asteroid and named it Oumuamua. It's very long, which makes it look like a cigar. Such forms have never been discovered among comets or asteroids in the solar system. Scientists suggest that Oumuamua came to our galaxy from the star Vega, located in the constellation Lyra.
Interstellar wanderers are the most dangerous because they are the hardest to detect. They can be quite large in size. Here, for example, is the evidence of such serious cosmic collisions. We observe in our solar system. Uranus's axis of rotation is tilted sideways. It takes a monstrous blow to turn the entire planet 90 degrees.
The main danger is that the interstellar wanderers do not have an orbit. They pass through the entire solar system like a bullet. It is likely that scientists will find such an asteroid only a few hours before it collides with Earth. How do we protect our planet in this situation? In Hollywood films, in case of extreme necessity, ballistic missiles are being prepared for launch. But is it possible to shoot down a meteorite?
Максимально тело может двигаться, встретиться.
The maximum speed that a celestial body can fly towards Earth at
Медленно движется.
is 45 miles per second.
0,2 километра.
The speed of a slow-flying object cannot be less than 7 miles per second.
Противовоздушная оборона.
The current real air defense tools that we are developing both in Russia and in America have never dealt with such speeds.
Ракеты
We can launch rockets at much lower speeds.
и, естественно, алгоритмы.
And of course, interception algorithms are designed for lower speeds.
So even the most advanced missiles require modernization to fight against asteroids, which will take years. And perhaps in the future, the leading world powers should revise the ban on the withdrawal of nuclear weapons from space.
Theoretically, an atomic charge will do for this task, but very specific missiles are needed. And maybe if they orbited Earth instead of being located on the ground, they would be better in terms of response speed and the distance at which they could detonate the asteroid. There's no need to waste fuel on launching the missile from Earth. It requires a lot.
It turns out that we need time for implementation of all projects to combat asteroids, but humanity might not have time on its side.